This is an example, is the example 19.7 of Giancoli 6th edition. And it looks like a complicated circuit. And the first question about this circuit is how much current is drawn from the battery. Okay, so let's have a look at what we have here. We have the EMF, right, and then the little resistance that is inside the battery, and then a whole many different resistances, some in parallel, some in series. And what we need to do, what we need to try to find is the equivalent resistance of this circuit. If I have an equivalent resistance from this circuit, I can find for sure the current, right? So the idea is, if I have a way to write this circuit just in terms of a single resistance, my equivalent resistance, then I can just use that the potential difference is Ri and find the current. All right, so let's try to find this equivalent resistance. So you stare a little bit and look for the piece of this circuit that is easy, that you can already substitute with an equivalent resistance. And this piece, this first piece, is this one here. So this part is in parallel. So let's try to substitute this part with an equivalent resistance. If you solve it in parallel, right? So the equivalent resistance for that piece there will be 1 over that equivalent resistance is equal to 1 over 8 plus 1 over 4. You solve this and you will find that the equivalent resistance for that little piece is equal to approximately 2.7 ohms. Okay, so instead of 6 here, I now have this new piece where up is 10 ohms, and then here I have 6 ohms, and this other piece now I substitute by 2.7. Okay, now I go on, stare this part, and you see that the first even trivial part to simplify is this part here. No? They are already in series, so instead of writing 6 plus 2.7, I'm going to put the equivalent part, which is going to be then, now I have the 10 ohms on top, and now here instead of the 2, I'm going to substitute by the equivalent one. The sum is 8.7 ohms. Okay, now I look at what remained here, and I see that this piece is in parallel, so I can try to substitute this piece here by a new resistance. So 1 over the equivalent resistance of this piece is equal to 1 over 10 plus 1 over 8.7. You solve solve this equation, you find that this equivalent resistance is approximately 4.8 ohms. All right, so very good. My circuit now, instead of this complicated thing, became, let's make a drawing of it, became, here we have the EMF, the little internal resistance of the battery. Now, this whole thing was substituted by an equivalent resistance, which is this one, 4.8. Okay, we simplified the red, then we simplified the green, then we simplified this blue, so this whole thing became simply 4.8 ohms. And we have that other one remaining 5 ohms. So this is our circuit now, much simplified. And with this circuit, I can already find the current, right? Because now all of these resistances are in series, so very easy to solve. What we have is that the current will depend on this EMF, right? So this EMF is equal to the whole equivalent resistance for this whole part here. So the equivalent resistance for this whole part here is just the sum of all of them, right? 4.8 plus 0.5 plus 5. So this is the total resistance, 4.8 plus 5 plus 0.5 multiplied by the current that we are trying to find. Okay, so the EMF we have is 9. This number you can get, and so you find the current. So this is the part A of the problem. All right, so we are done. We got the current. If you go through the whole thing properly, you will see that this current is it's 0.87 amps. Done. So this is part A. Let's go for part B. Part B asks what is the terminal voltage of the battery. I was playing here with the EMF, but we know that the terminal voltage of the battery is the EMF minus what goes through the little resistance. So the potential difference will be 9 volts, right? 9 volts minus this current multiplied by the little resistance, the little internal resistance of the battery, and then we will find that this potential difference is actually just 8.6 volts. All right, now comes the last question, and the last question is what is the current that goes through the 6 ohm resistor? So let's go back to our circuit. We want to know what is the current that goes through here, through this resistor of 6 ohm. Now, do you agree that the current that goes through here is also the same current that goes through here? All right. The current that goes through this piece has to go through everywhere. The resistance of this whole part here is that 8.7. Okay, so if I find the current that goes through this equivalent resistance 8.7 here, I know that this is going to be the same current that goes through this whole piece here, and therefore is the current that goes through this 6 ohm. Okay, I'm saying that because instead of thinking too much in terms of the original circuit, I'm going to think in terms of this simplified piece. Okay, so let me finish this simplified piece. Here we have the little resistance of the internal of the battery, right? This is the EMF, and this is the 5 ohms. Okay, so we already found what is the potential difference of the whole battery. So this whole thing here, we already know that this is 8.6 volts. Now the EMF inside was 9 volts, but the whole battery is 8.6. Okay, so I have this potential difference that is 8.6. I know that this 8.6, which is the potential difference of the battery, is equal to the potential difference for this part plus the potential difference for this part, correct? In other words, when I have a battery and 2 resistances, I know that this potential difference here is this V1 plus this V2. This is what we saw in class, right? So this whole potential difference, VA minus VB, is equal to V1, right? V1 would be VA, and here there would be a C. So V1 would be VA minus VC plus V2, where V2 is VC minus VB. Okay, so VA is here, everywhere around here is very close to VA. Then I have a drop, I called it VC. Then I have another drop, I call this point VB because it coincides with the other edge, with the other potential of the battery. Okay, so this is to remind us. And now coming back to that simplified circuit, what I have is that potential difference of 8.6 is equal to VA minus VB plus VB minus VC. Okay, so this 8.6 is that VA minus VB plus VB minus VC. If I know this potential difference here, then I'm done, because then I'll be able to find the current that goes through that resistance 8.7. If I know the current that goes through 8.7, I know the current that goes through 6. Okay, it's all the same branch. Okay, how can I find this potential difference VA minus VB? Well, I have to think a little bit, but then let me stop and move to the other one. How about this one, VB minus VC? Do I know? Well, remember, potential difference is resistance multiplied by the current. The resistance for this part of the circuit between B and C is 5. And what is the current? It's the current that goes through the whole circuit. Now, the current that goes here will split. Here we'll have a piece of it, here we'll have another piece of it, but then it gets together and I'm back to the whole current that was is drawn from the battery. Okay, so this current here I have is the one that we obtained before, 0.87. Okay, so I have this potential difference is just 5 multiplied by 0.87. So that with this I can find the potential difference that I need between A and B. Okay, so the potential difference that we need is the potential difference from the battery, which is 9 minus the potential difference from the little resistance, no? So 9 minus I multiplied by 0.5 is this 8.6, and then this minus this value that we got here, 5 multiplied by 0.87. And if you compute this, you will get the value of this potential difference. With this potential difference, then we can find the current, the green current here, which I'm calling I2. So with this potential difference, we know that this potential difference is I2 multiplied by that resistance, and so we can find I2. What is this resistance that we need to enter here? The 8.7 ohms. Okay, this current that I'm going to get, this I2, which goes through this equivalent resistance of 8.7, is the same current that goes through here, that has to pass through these 6 ohms and then through this other piece. So it's the same current that goes through here and then it will split, but it's the current that does pass through 6 ohms. So that's the idea of this problem.